Today we are talking about inverse functions. Inverse functions are going to undo a function. So if your function is a Coke machine, you're going to put quarters in the Coke machine and you're going to get out a Coke. The inverse of that Coke machine is when you put a Coke into the machine and what would you get out? You would get out quarters, okay? So an inverse function undoes the function. That's what we're talking about today. You can look at a graph to see if they're inverses by drawing this line right here. Has anybody already had this lesson? Do you know the equation of this line?
Oh my god, my charge is not working now.
Do you remember y equals mx plus b?
Oh yeah. I learned that back in algebra or geometry.
Miss Brooke. I'm god of
Miss Brooke.
So a line is y equals mx plus b. This line has a slope of 1 and a y-intercept of 0. So this is the line y equals x. All right? The line y equals x is special for inverses because here's a function. Here's the inverse of a function. Do you see how they're symmetric to that line?
Yes.
So if you were looking at a graph and the teacher asked you, are these two inverses of each other, you could draw this diagonal and look to see if there's a reflection. Here it says, show that f of x equals 2x plus 6. That's the graphed one right here. And g of x equals 1/2 x minus 3 are inverses. And then graph g of x. So the way that you show that two functions are inverses is you're going to do f of g of x, and then later you're going to do g of f of x. Okay? So you start with function f. Function f is 2x plus 6. And instead of the x, you're going to put parentheses. That's function f.
Wait, Miss Brooke, can we turn off the front lights?
Can you open up the window? It's warm in here.
Okay. We can try it. You can try to turn off the lights, but it's not like just front lights, back lights. So if you want to go try it, go ahead.
No, I'm sweating.
Okay.
Why do you have your jacket on? You're sweating. Why do you have your
All right. And we are going to discuss just math and not the weather yet. Ready? So it was 2 times something plus 6. Now the thing that goes in the parentheses is function g. Function g is 1/2 x minus 3. Let me see if I zoom, if that helps you see it a little bit better. Okay, so now what we're going to do is distribute the 2. Does anybody know 2 times 1/2 what you get?
1.
Good. So this is 1x, and then 2 times minus 3 is minus 6.
Can't you just put X?
Plus 6. Yes, you can just put x. I'm going to do that. That was a good suggestion. So that's going to give you x. What about minus 6 and plus 6?
They just cancel, right?
They cancel. Good. So your answer is x. Now we're going to do g of f of x. So you start with function g. That's this one. You do 1/2, but instead of the x, you put parentheses. And then you do minus 3. Then inside the parentheses, you're putting function f of x. Function f of x is this one, 2x plus 6. And then you distribute the 1/2. So we said 1/2 times 2 is 1, so that's 1x. Or Riyadh said we could just put x, that would be even simpler. And then 1/2 times 6. And then bring down the minus 3. And what happens with the plus 3 minus 3?
Cancels.
It cancels. Good. So if you do f of g of x and you do g of f of x and your answer is x, that means that the second function undid the first function. And you got back to your original x. So that means that these two are inverses. So when you do this, you want to make the conclusion f and g are inverses. And if you're really happy about that, you can give it a happy face or a rainbow, whatever you like. Okay?
Miss Bell, can you go to the bathroom now?
When we finish these notes, yeah. All right, now then it says they want you to graph it. So we're going to graph 1/2 x minus 3. So start at -3 and do a slope that's up 1 and over 2. And you can use your student ID as a straight edge. You need a straight edge right here. And if you did it correctly, you'll see that here's my line y equals x in the middle. These two lines are symmetric to that line y equals x. And then back here under visual verification, we forgot to fill that out. It says if two graphs are inverses, then they will be reflections across what line? You guys remember we figured it out? They're going to be reflections across
Yeah.
y equals x. All right, so this one was a little bit of work. It's not so much work, though, when they ask you to graph the inverse. It says either graph by reflecting over y equals x or naming points and switching the x and the y. So if I want to name points on this one right here, I could name this point, which is 0, 5. And I could name this point, which is 1, -1.
Wait, so how do we figure out their inverses again?
We put the function g inside the function f.
Okay.
So we did f of g of x, and we put the function f inside the function g.
Okay.
So we did both those things. All right, so now in this graph right down here, sorry, I forgot that you couldn't see it. I found 2 points on the line. I found the point 0, 5 and the point 1, -1. And now what I'm going to do is I'm going to switch the order. So I want to graph the points 5, 0 and -1, +1. See how I took that and I switched the x and the y? And now I need to graph those points. So 5 zeros here, and -1, +1 is here, and then use a straight edge like your student ID and make the line through those. Okay, so look at the next graph. Can you name a point that's on the graph? Did you find one, Misha? Look at the graph here. It's like a parabola. I want you guys to see if you can name any point that's on that graph. This one right here? I think that one's 0, 1. 0, 1. Good. Is there another point on that graph? Kind of hard to tell. 2, 5. So 2, 5. I agree. Good. Okay. So the points that we found on the graph were 0, 1, and 2, 5. So we're going to switch the x and y. So instead of 0, 1, what should I write? 1, 0. And instead of 2, 5, it's going to be 5, 2. So you want to graph those points. 1, 0 and 5, 2. And then you want to draw the same shape. See? So that shape is reflected across the line. All right, what questions do you guys have before we find the inverse of these two functions? Okay, for the last two, what we're going to do is switch x and y and then solve for the new y. So instead of y, I write x. And instead of the x, I write y. And then I have to get the y by itself, so how can I get rid of the 5? Subtracting it would work. So x minus 5 equals -y. How can I find positive y? Well, I could add it and move it here, but then I'd have to move all these over here. Is there another way? Divide by what? Negative 1? Yeah, I can divide by negative 1, because really this is the same as negative 1y. So I can divide everything by negative 1. So I get y equals x divided by negative 1 is negative x, thank you. And then negative 5 divided by negative 1
Plus 5.
plus 5. Okay. You can have your y equals on the other side if you want. I just never moved it. Alright, any questions before we do the last one on our inverse functions notes? Okay. First step, switch x and y. So this is x, and this is y. Okay, now I have to get y by itself, so what do I have to do to both sides? Subtract. Okay, how do I get rid of the third power? Okay, but instead of like raising it to the third power, I want to do the inverse, which is to do... Okay, I'm going to combine your ideas. It's a cube root. So we're going to do a cube root on both sides. So we do a cube root like this. And we do a cube root of the y to the third. And because cube root and raising something to the third, those are inverses, those cancel. So the y is by itself now. And the left side does not simplify. It stays cube root x minus 5. And that's your inverse. Okay, so I'm going to stop the video.